All right. Oh, go for it. Thank you very much.
So, yeah, this is working great. Thank you very much for having us here, Matt, for organizing everything. Thanks for being here on a Saturday. I think it's very impressive, and thanks for the dedication. Before starting out, I just wanted to see a little bit of the audience that we have today. How many of you, please raise your hand, those who are working or coding with iOS. Awesome. That's great. Yeah, that's great. Expectable, I'm going to say. That's great. How many of you are coding in Objective-C? How many of you are coding in Swift 2? How many, okay, Swift 2. Okay, how many of you are coding in Swift 3?
Oh, you mean versions?
Yeah, versions.
I thought
versions.
Swift in addition to Objective-C.
No, versions of Swift.
Okay.
Okay.
None of the two.
Okay, that's great. I like this because we have a kind of a diverse audience with different experiences in different languages, so it's going to make the talk even more interesting. So let's see if this works. Yes. So a little bit about me before going into the technical stuff. I am Juan. I'm a software engineer and iOS developer from Santiago, Chile. So you can imagine that it's been a long ride to here, in my case. If you count the stopover in Toronto, for me it's been like 30 hours to get here. It's gone a long way. The cool fact is that if you actually dig a hole in the ground right now, you'll get to Santiago. We're total opposite, so that's kind of a cool fact. Besides being a software developer, I do a lot of things. I speak at events. I'm a musician myself. I have a couple of tracks on Spotify. You want to check them out by my last name, which is Karmy, K-A-R-M-Y. I very infrequently write on my own blog about engineering and different things related to software, so you can check it out. And I've been building apps since 2011, when kind of the boom of apps started to grow. I've written a couple of apps over the years, mainly for startup companies that many of them have not succeeded, but some of them have done really well, including a couple of apps that have gone to the top chart in local stores. And recently, last year, I did write what I call the Swift summary book. Have any of you heard of the book or have downloaded the book? Raise your hand if you know the book. Great, someone in the back. Great. So basically, what I wrote was, in order for myself to get updated into Swift, I basically went through the entire Apple documentation, going chapter by chapter to learn about the language. And what I did was I wrote a summary for myself. But what I did is learning language from a PDF, from a static PDF on the web is not the best way, especially for developers, for us developers. So what I did is just, let's write a summary version of this, which is less text, less information, just the gist of it. And I also wrote it in an interactive way, which I wrote it in Playground's platform, right? So something that started to be like a personal project just for myself ended up being like a full compiled material of the summary of the documentation that's interactive. So I said, let's put it to the public. And what I did, maybe we can talk about this with Ruben later on, that was interested in this, I did some marketing on it. And I posted it on all the social networks. I did a lot of posts on Facebook and Twitter, and I also released it officially as a product on Product Hunt. And to my delight, it did very, very well within the first 2 weeks of launch. So just to give you kind of an impression of what this made, the product went top 1 within the first hours in the books category. it reached over 280 upvotes in the books category, which makes it officially one of the most upvoted books in the history of product hunt on that category. And that allowed the book to have, the book has been released on GitHub as an open source resource, and that made it get over 1,500 stars, which is like, it's amazing to see how people were interested in the resource and the demand for this kind of material, which was amazing. On the way, a lot of praise from different companies and different professionals from Amazon, eBay, Groupon, Zynga, Pivotal, you name it. A lot of people were like fascinated by the product itself. And you can go right now to swiftsummary.com. You can get basically clone the repository, fork it, give it a star. I'll appreciate your support of that. So I'm very happy with it. And what I've been doing lately is basically talk about Swift, talk about playgrounds, and different things that are very interesting between the transition from Swift to Swift 3. So how many of you have used the playgrounds, I'm going to say widget, from Xcode? Okay, cool. That's great. So I'm going to talk about a little bit about playgrounds and how I've used it to my advantage to create the book. So I'm going to start with a basic meaning of what playgrounds means. You look it up in the dictionary, it would say a place where people can play. And that's exactly the kind of the motto for the Playgrounds platform, which is somewhere where you can actually play with code. You can basically use Playgrounds for anything, for typing scripts, for piloting code before shipping it into an app. It's very useful for isolating code that you want to run without affecting other people's code. And it's great. Now it's even greater because you can actually debug and test interface in real time with your code. And it also serves as shipping educational material or tutorials, etc., like the Swift Summary book. So some of the features that I really like about Playgrounds is, for instance, pagination. So before, the Swift Summary book was literally a folder with every chapter being written on a different separate Playgrounds file, which it was okay at the beginning, but it was kind of cumbersome to go from one chapter to the next. So of course, oh, I'm going upwards now. No, the animation. Okay, so now what I've done is basically compile every chapter basically on one Playgrounds file, and you can jump back and forth from one chapter to the next just in the blink of an eye. So that's very convenient for longer material that has many sections. Another one is access level that I really like, especially if you're doing like a demo app in Playgrounds. You can, on every page, you have a dedicated space for resources and source files. So you can drop there, for instance, I'm going to say a struct or an enum or even a specific class on Swift that's only going to be accessible from that page and not from other pages. So you can isolate access and code for specific purposes, which is really interesting. Another thing that I really like from Playgrounds is the inline printing it provides. So basically when you're testing code, you can basically see in real time the result of what you are working on below as a preview of what's happening. So I'm actually gonna show you a little example that I have. It's a little demo. So bring this here. Need to adjust it though. Can you do this? Bad idea.
I think you can click Option at that bottom.
No, it's kind of stuck now.
It's stuck in the full size.
It's really stuck. There you see that. I really dislike that feature.
If you double click the title bar, it can also resize the window to the size of the screen.
Okay, so
By double clicking on the title bar.
awesome. Thank you very much for that. And I'm gonna get rid of this. So as you can see here, I just resized this for educational purposes. So it's big on purpose. Basically what you can see here, this is just a minor example, but one of the cool things is that you can see in real time here what's happening with the data. So for instance, sorry, there we go, getting around. So this is the one that I know. There we are. So for instance, this example is calculating fuel paths. And for instance, here you can see that something's happening. And you can see in real time, for instance, what's happening with the value of what's executing in that moment, which is very convenient to visually have an idea of what's going on. Here, for instance, it's indicating the best travel time, so you can see how it drops whenever there's a new optimal solution to this problem. And it's not only great for visual things, but you can also see data from arrays, data from different, from different containers. Well, in this case, it's kind of weird. Yeah, 3 dots. I don't know what that means from that in particular, but here, for instance, yeah, you have an object and you can really explore what's below. You have previews of what you're loading in case of images and static content, which is very convenient to just have a glimpse of what's going on. Going back to the presentation, that's inline printing. You also have live views. Live views is very, very interesting because it allows you to compare your code directly with your user interface in real time. So to give you an example of that, if we go back to this example, where's the mouse? Here. So I'm just going to reload this and go here. You can actually open the inspector here, or the side view, and you're going to have a preview of the interface that is being loaded in that moment. And as you can see, it's in real time checking what is the best route to do like a mini tour from. I think it's from whether the market in San Francisco to the airport, but it's going through a lot of different spots in the city. So that's very convenient to basically see in real time, okay, I can update my UI on a loop or on a certain process and see what's happening. And that's very convenient without having to go through Xcode and running your app, and basically a much slower process than just, I just want to try the code, right? And the last thing that I really like from Playgrounds is the markup capability that it has to really enrich the reading of the code. So, as an example, we have the same file, the same San Francisco example. I'm just going to kill that. And as you can see, one of the things that it really caught my attention is that when we write code, we usually comment on it. Okay, we comment on it so the next person is going to be able to know what we're thinking, and a lot of the mental processes is put there. The problem with that, and what I don't really like, is that comments are written in the same syntax, with the same fonts than code, so it looks like code, right? In my particular view, I don't. It looks like there's a lot of code in this particular page, although it has different color. but it looks a lot like code. So what they did with playgrounds, and that's why it makes it such a great educational material, is that you can actually write markup code in playgrounds with their own syntax, and you can actually go to the editor, to the editor, and show the rendered markup. And when you do that, you have like a book layout of what's happening here, actually, with notes and with hyperlinks and with everything. And then you have the code followed by space. So all the comments are transformed into paragraphs. And then you have the code with all the typical syntax and the typing and the colors. And the final result is that makes it look like there's actually less code in the whole page, which is great. I mean, we want to just write the sufficient amount of code and makes it look appealing to the eye. So actually, if I just resize this to a normal size, it looks more like, oh, this is kind of a book on this example, and it makes it much easier to the eye. So that's another capability that I really like with the new in the playgrounds. So what I want to talk about now is about the transition from Swift 2 to Swift 3 and some of the cool things that, some of the important changes that have been happening and why they've been taking place. So I would say that Swift, especially Swift 3, is focused a lot on clarity and having less redundancy. And a couple of examples on that is, well, first of all, I'm going to, for those of you who have not coded Objective-C in a while, I'm just going to do a little flashback in which that with Objective-C, once upon a time, we had something like this for building an array, for instance. Is there anyone here who did not see Objective-C before? Everyone's gone through the pain. Okay, that's great. You're vaccinated against it. Okay. So yeah, I mean, this used to look very natural for us after we got intoxicated with Objective-C. But if you take a look at it, now that you've written Swift, this is like super ugly. I mean, what is that? Like, whenever someone sees this, is like, this is just alien to everybody. And it's very verbose. It's filled with unnecessary jargon to this language that doesn't need to be added. The same thing for writing functions or methods. It's really weird the fact that you have this colon and then you have to follow the parameters with spaces and the custom names. So it's really messy. And then the fact that you're really messaging an object rather than just calling directly a function. So it's all very messy at that point. So then we have Swift that changes that dramatically, and then we have Swift 3 that takes things to a slightly better level. So for instance, to give you an example, in Swift 3 first of all, this already looks much better than Objective-C, but it could look better. So we still have a couple of things like carry on behavior, which is this thing like append contents of remove at index, which means that, so if you take a look for that call, remove at, we're going to have there are a lot of removes at, but we have to create, or there's a different function really for every different call. And if you compare it to other languages, it doesn't really work like that. You have an override, which it depends on the parameter that you're passing, but the main structure of the call, the function, remains the same. And that's what Swift 3 has done, which is basically you have a consistent name for one method that can be overridden with different parameter calls. So they basically put the differentiator inside as the different parameter, right? It looks much better. Is that even though they have done that, certain parameter labels already were redundant. Like in this case, for instance, when you say array insert, so yeah, I'm inserting something, into an index. In this case, it's pretty obvious that I don't have many more options of specifying where I'm going to insert that number 1, right? It's not like, am I going to insert it in somewhere else that's not an index? No. So that at index is already a little bit too much. So what they do is, okay, let's minimize this to the minimum expression, basically. Okay, at already implies it's an index. Another example is, for instance, the same thing goes with dictionaries or hashes where you have excessive vocabulary, like remove value for key. They also did, okay, the for key we're going to put it inside, and we're just going to leave the remove value as a general call. So those are like the basic things that they've been improving in Swift 3. This is a very iconic example, which is ANSURL file row with path, file URL, appending path with component. There's a lot of repetitive material here. For instance, with path, we could have only file URL and then add the with path as a label for the parameter. Also, and if you've worked, I'm interested with those people that have not worked with Swift 3, those who have worked only with Swift 2. What does file URL mean? What does URL.fileURL mean? What does that do? Anyone?
It adds file colon / from URL and make sure it's absolute.
So I'm talking about the second line.
Yeah.
So you say that does what?
When you use file URL,
Mm-hmm.
like file URL resolves it as a URL for the file system. Like file colon / whatever var, all that junk,
Okay.
where it sits on the disk.
So according to you, the second line, what it would do is transform URL into a file URL.
Generally use file URL instead of URL to specify it's an absolute URL on the disk.
Mm-hmm.
To get Apple's magic URL.
Apple's magic URL.
Yeah, because like everything is on the disk.
Right.
If you don't know where it is, you can't
Right.
access it.
Right.
So within your app.
So yeah, but basically, let's say in a very broad level, it would do a transformation to that URL object.
It can extract it, but yeah,
Okay.
yeah.
Okay. So that's exactly what that call doesn't do, and with good reason, because it's totally misleading. In Swift 3, they changed it, and it is file URL, which actually what does, it returns a Boolean value telling who write that. I mean, is this a file URL, yes or no? It doesn't do a transformation, but it will just tell you, okay, this is a file URL. So you can understand how misleading some of the calls were in Swift 2, and they were not really intuitive just by reading it. So that's a lot of things that they've been working on, is making it more readable. A lot more in clarity too. So for instance, this call in particular. Sometimes, in particular cases, there's a function, and we don't really care. We're really interested in what's the inner process of that function, but not necessarily in what's on what the resulting value is. We just care about the operation. So at some point, we have to call that. Now the problem is that whenever you see, I mean, okay, this is a perfect world scenario where the call is right below the declaration, which is not the case all the time. So you will see this in a completely isolated way, and you say, what the hell is +1 doing? Like, why is this just isolated in the world of the code that I'm seeing, and like, no one's taking care of this? And so what they did to clarify that you only care about the process, you basically don't care about the result, is they added the underscore to specify that. Basically, they were more specific at, okay, what you're doing is, I don't care about the result, I just care about what's going on in the function. And that is explicitly written. So it's much more clear for someone who's reading the code, okay, I don't have to worry, or this function is for something very specific. Another thing is that I really like it, it's more readable. they actually got to the convention that depending on how they write, the writing or the grammar of the verb or of the code of the call, it means something different. So in this case, you can see that reverse means that it's actually mutating. It's mutating the result. The object, and reversed is not mutating, and it will give you a different value. Will return you a value which copied the array but reversed. And the same thing happens with URL, which will whether change the object that you are passing, or it will return a different copy with the modified value. And you can basically know that just by reading the call and not having to go through definitions and things like that. So let's talk about sex now. Not really. If you guys were thinking something else, you're wrong. This means Swift evolution, XXXX. And Swift evolution is really a page where basically, has anyone really reviewed this before? Raise your hand who's been, okay, you guys have been reviewing? Okay, that's great. You've been catching up with latest in Swift now. Basically, it's a section where you can see how the review process for different proposals is going. So proposals that are submitted by different developers, whether they get rejected, accepted, or in review, they're being implemented. You can see the current state of the Swift language. And some of the proposals that I think are very cool that have been approved are some of the following. So for instance, consistent parameter labeling. So the first thing is that there's a function that's declared as ABC, and then when we call it, we have this, where in Swift 2, you could omit the first label, which is also kind of a carry on from Objective-C. So what they did is, okay, no, we are just going to add all the labels that were declared on the function, which makes sense. Another one that I really love is the plus plus and minus minus operators are being completely eliminated, and that's awesome.
Why?
Someone said wrong?
No, I said why. Why
Oh.
do you think that?
Why? Well, one of the reasons, first of all, why is it, for what it's being replaced is for basically the typical syntax of plus equal 1. And the plus plus operator, it's cool. It's kind of a cool thing in the beginning when you're learning. Oh, I can do plus plus, and it will add automatically, right? It's kind of a cool thing, but it doesn't really have a lot of. Number one, it doesn't have really a lot of context. If you are for the first time seeing that, you don't really know what it means. Like, what does plus plus means? Number two, why is there only plus plus? Why isn't there a plus 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 and plus 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 and plus and so on, so on, so on? Right? Why am I limited to that? Number three, this is mainly used in loops and iterations for basically adding, kind of a fast way, incrementing one by one, right? And they are basically deprecating all of those things to highlight clarity and to be specific about the language. Yes?
I think my understanding is eliminating plus plus and minus minus, because when you're constructing a much complex expression,
Yes.
and then sometimes it's minus minus, and then when the compiler try to optimizing the code, and you don't. Sometimes there's ambiguous cases where this is number b because of some plus plus or minus minus, which in a very complex expression, and which one should be evaluated first or not. So this is, I think this is a kind of problem all the C from C++ world.
C plus equals 1.
So yeah, I had some problem, same code, but some compilers evaluated this first, and the other compiler evaluated first. Then, as long as we go for plus equal, and you don't have this ambiguity,
Right. Right. No, great. I mean, great. I'm sure that if you can avoid compiling errors or ambiguous situations, that's even better. I mean, you're basically tackling different problems. One of the problems that actually they highlight at the proposal is basically an ambiguous declaration that it is not clear what it means. And the next reason why this on Swift doesn't really make sense anymore is, so yeah, we're gonna come back to that in a couple more examples, but you're gonna realize, you're gonna make the connection. Another one is, for instance, collection indexing. You have on Swift 2 a pretty neat and pretty nice method for, so for instance, I'm just saying a number, it could be an integer or double, but basically you could call successor. And what it did, it was basically incrementing by one, or going to the next following number, and you could use that for iterations. Now the problem with that, what's the problem with that, is that the number and the successor is completely detached from the original purpose, which was going through a collection or an array. So once I call a successor, I could be out of bounds, and there's an exception, right? So I have no context with the original purpose. And Swift 3 tries to correct that by giving me, I can call now the collection itself and ask for an index that is whether after or before the number that I'm passing. So that is something that has a lot more context and is bound to the collection. Eliminate this classic writing. The ++ really is very limited in where you'll use it, in most cases, right? So that's why they said, it's even, these two things are really interconnected, so we better basically discard both of them. And all this is in the spirit of being much more clear and specific and avoid basically mistakes. This is a syntax that is much clearer that I am within the bound of the array, right? That I am basically iterating its content, and it's much more clear in that sense. This syntax is messy. It goes back from the C loop, right? But if you're designing a language now, and if you're designing Swift now, it does not really, it doesn't look Swifty, okay? It is just something that, first of all, for newcomers, adds a lot of, I'm going to say, like a curve, for a learning curve, basically understanding, what's the semicolon doing there, right? I basically have to adapt to a special notation for a loop, which, it's kind of overdoing it. And this is much simpler. So those two things are kind of interconnected.
Sorry, maybe I missed something. What is that array I in there? Where do you get that I from?
I'm sorry, where?
The Swift 3 and the print array I. Is I.
Oh yeah, that's a. I don't know. Well, this is a string.
That's a string.
Yeah. So it doesn't really matter what I write there.
Okay.
Yeah. What it matters is what's there.
Okay.
Because if that were I, that would be an error.
Okay. All right.
But semantically speaking, you're right. That's incorrect. It would be much clearer if that's index. Was there another comment about it? Or yeah.
So the Swift 2 version, you're saying you can't do that now?
Which one?
Swift 3. So you can't actually do a for loop in C style in Swift 3?
Yes.
Okay.
Yes. So it's, I think it's kind of a big step, but they're taking a lot of these big steps to make Swift stand out, to be super clean and super, basically avoiding mistakes. Like if you take a look at the Swift syntax and how it's done, it's kind of safety for kids, basically. It's like improving safety and avoiding null values that are going to crash your code or things that are not defined, etc. So it's great in that sense. Floating points and numerics. So for instance, in Swift 2, you could do that. You could basically call a mathematical function and say, give me pi, right? Now, the problem with that is that taking advantage of the dynamic type definition, I'm going to get, I don't know what I'm going to get. I mean, var pi equal m pi, what am I getting there? By just looking at that, I don't know if I'm getting an integer or a double or a float. I can't read that and know, okay, I'm prepared to do the next thing. So what they improved is now you call the type, the class, and you say, okay, give me a pi number. So that is much more clear in terms of, okay, I know that I'm getting a float, I know that I'm getting a double. In-out for type declaration. Who's been using in-out lately? Cool. Great. So one of the things that they had in Swift 2 is that, well, for everybody who doesn't know what in-out does. Okay, it's okay. In-out basically what allows you to do is whenever you pass a parameter, I'm outside the function. I call the I have, let's say I have airplane and basketball defined before the call of a function, and I pass airplane and basketball as parameters. If I modify, in-out allows me to modify these two parameters that are passed, and the value is written back to the original variables. On Swift, in spite of safety and all of these things, if you don't add the in-out label, you are not allowed to modify the original parameter.
So it's kind of like the closure, you're breaking the closure basically.
Exactly, you're basically going through the function and writing back to the original value.
Gotcha,
okay.
Gotcha.
So that's basically for context. But the thing that is not clear here is that, okay, so the convention is I have the parameter label, and then I have the parameter type, which is a and int, right? But then I have in-out, which is kind of a type for the parameter, but it's before the label. So what they did is, okay, let's make this a little bit more consistent. And what they did is, okay, now in-out goes after the parameter label. So parameter labels are to the left, and everything that's related to the type or to the kind of that parameter is left to the right. So they kind of put some order in that. Talking about in-out, what they did is also remove another capability. So also, aside from in-out, you had var. So the slight difference between having in-out and var is that var allowed you to, if I'm not mistaken, allowed you to modify the value inside the function, but it didn't write it back to the original declaration.
So standard closure.
So it's still closed. So what they said is, well, in-out, if we don't do anything, it is completely closed. I mean, nothing gets out of function. If we put in-out, everything gets written back. And the use case for var, which is kind of in the middle, was the usage was not, the use cases were not a lot. So they did, you know what, we're just going to discard that. So what they did is, okay, in Swift 3, you cannot use var anymore. There's only in-out, which basically covers most of the use cases for doing that.
If I could just check and clear this with everyone, I believe if you have a parameter, for example, your I, just as it is at the bottom, without the in-out, just I is an int, then inside the method, you cannot change the value of I.
Yes.
Right.
Yes.
And var would allow you to, so it comes in as a copy, as a constant, basically
Yes.
as a let, and so you can't change the value. If you really wanted to, you could say var my I equals I, and then inside the method you use your copy.
Yeah.
But so adding var would allow you to just automatically use it as a variable inside the method.
Exactly.
In-out is not that it's the written back. I mean, the values are passed by value, copied by value. So what you send in a whole new copy is made and used inside the method.
Yeah.
And in-out is by reference, basically, so allow
Yes,
it to
so it writes back.
write back.
So yeah, basically, here you're able to use it as a var, so you're able to modify I inside, I mean, right here,
Modify the copy.
but it's just a local
Right,
change, right?
So,
Right.
so wouldn't you, I mean, in-out is not necessarily the solution for this in Swift 3. I mean, you're saying instead of var, use in-out, but those are two separate, complete separate different things.
Oh, I'm not encouraging, I'm saying Swift 3 deleted var. Like,
Oh, okay, because well, your example here is tagging on in-out. It makes it look like to change, if you want
No,
the same
so-
functionality, you would do in-out, but they're different.
No,
things.
what I said is basically what they did, the logic behind the change is that they said the use cases of this one were very limited compared to whenever you wanted to do something like that, you would use in-out. In terms, that's kind of some of the arguments that okay, so when would you use this one?
You would add a var if you wanted to specifically do calculations
Yes.
that included changing that I value
Yes.
inside of the method only.
Right.
In-out is
Right.
specifically when you want those changes on the object that
Correct.
originally was passed
Correct.
in. So
What
the
I'm
reference-
saying is, correct, I agree with you, that's the definition of what we're talking about.
Right.
What I'm saying is that the argument is that in most use cases that you ended up using that, right, in-out was most frequently used.
I think what he's trying to say is actually in-out shouldn't even be on the same slide as the var concept or orthogonal concepts. One is about whether or not you can adjust something within the function by creating a local variable or just reusing actually the parameter as an editable value.
Right.
Whereas the other concept is, do you even get a copy or do you get a reference to something that exists outside of the function?
Yes.
Right, so he's just saying it's a little bit strange that they're on the same slide because they're really unrelated concepts.
Well, you're showing Swift 2 and Swift 3,
Well-
so it looks like you're saying instead of using var, you should use in-out, but that's not the case.
No, that's not the case.
Okay.
That's not the case. The case is that this specific proposal, what it does is that it eliminates this possibility of declaring variable inside the using the variable, and you can basically, this no longer exists. If you wanted to do something like this on Swift 3, the only kind of similar replacement, which is not replacement, but the only kind of similar thing without having to declare variable inside, okay? The only thing left out is in-out.
But they're completely different.
They're completely different, okay.
In the Swift 2 case, you're safe. You're using a local variable.
Yeah.
It's not going to write back. But you can't say this is kind of similar because that will write back and
Okay.
then the functionality is
Okay, I agree with you that maybe there's not much of a relationship. So if you wanted to compare apples with apples, the var now would have to be declared inside and do that kind of thing
I just
inside.
don't want anyone here to look at that and say, oh, so if I want to change the value inside my function, I should do in-out. Because in reality then, the original caller, what was passed in, will
yeah,
change.
okay.
Yeah,
Yeah,
so
yeah.
that's bad.
Thanks for the clarification.
I also need to point out we're over time now, so we're going to wrap up.
Yeah, okay, so I have a couple of, yeah, it's super short now, don't worry about it.
Yeah.
So after going through everything, basically, the Swift summary book, I wrote it on Swift 2, and then Swift 3 was out, Xcode 8 was out, and of course, this happened. Okay, opening up the whole book, it's like, oh crap, like I have to update everything again because now it doesn't compile. What I want to tell you is that for everyone who's trying to do the transition, Xcode kind of has you covered because they have, they have an automatic upgrader. Actually, I just want to show them real quick with an example. So if we go to this demo here, I'm going to open up this with Xcode 8. It's a little demo that was written on Swift 2, and this is probably not going to compile. So there are a lot of errors here. I'm going to go to the editor and actually show the raw markup. Sorry. Oh, right there. This had to go here. Right. So I have a lot of errors here because some of the calls are no longer available. So instead of going one by one here, what you do is you can go to Edit, you can go to Convert, and there's a neat option that says to current Swift syntax. So I'm not thinking of it. This is way too big. Yeah, this is way too big. But basically, here you have kind of a comparison between the two versions of the code that you have right now and how it would look like after the conversion. Now, I don't know why they did something like the after conversion is to the left and the before conversion is to the right, which doesn't make any sense, but that's how they did it. And you can review the code and basically go enter, and everything is automatically changed to the current syntax. So that's really neat, and you will avoid many you will save time upgrading, but you have to be careful with some cases where basically it will lack content. So for instance, here it was the i.successor, and it replaced it with i+1. I didn't really want that. I wanted the new thing, which is getting the index from the array. So you would have to. That's why it's useful to review the code before you just go ahead and click OK. So just to wrap up, because we're a little bit over time. The Swift summary book is available. Actually, right now the community is working on markups to update it to the latest version. And I would really enjoy if you could actually take your laptops, the ones that have laptops, to go to swiftsummary.com and give it a start on GitHub. That would be really, really cool, and it would mean a lot. Actually, we're a little bit over time, so I'm going to skip the part where I say that I have a minute to wait for everybody to just start starring the book, and there's like a dynamic star that's just start falling. So if you could just do it right away, it would be amazing. I think I can't stop the animation. I think, but no, I can't stop the animation, so I have to wait for it. In any case, the book was meant to help everybody go from Swift 2 to Swift, basically to learn Swift. And to anyone who's not been upgraded yet from Objective-C, is a really fast way to just get the gist of the language, chapter by chapter, and even make your own modifications. You can just start typing, you can change everything, and basically make it your own. And if you have any suggestions or you want to make pull requests, they're more than welcome. So that basically finishes the presentation. Yeah, thank you very much. So, do we have time for like a mini questions?
2 questions.
2, yeah, okay.
As I walk up there.
Okay, questions?
Can I ask is how is Swift concurrency features compared to like Rust language?
I'm sorry, Swift concurrency?
Swift concurrency compared to Rust language.
Rust language?
Rust language.
Oh, Rust language.
Yeah, Rust. Or it doesn't matter. How is concurrency?
I wouldn't be able to. I wouldn't be able to respond. The Rust language.
Yeah, Rust is a programming language. It's made by the Mozilla Foundation.
Oh yeah.
Yeah.
Never touched that.
They
So.
had a blog post a couple months ago. They basically haven't implemented any of the concurrency features yet.
Okay.
I think it's for 2018. They want to have it done. Maybe I think that's what they said.
Okay.
But they did clean up libdispatch for Swift 3. It's dispatch queue.main.async. It's much cleaner to do those calls.
Questions?
Maybe another one. Sorry.
Yeah. Go ahead.
Okay, we know that Apple has open source Swift
Yes.
about a year ago, and
Yes.
how is it being adopted to non-Apple platform development? Say, for example, web applications that has nothing to do with iOS or
Okay. That's
and
actually,
connection to databases, and so on. So
well, that's actually part of the purposes of opening Swift, that the community basically can do whatever they want with it. Right now, you have a lot of, you can see, especially on GitHub, a lot of initiatives and a lot of projects that have been created, people that have created entire backends in Swift that you can just basically start from there, mounted on your own server, and you have a server on your backend on Swift. I think that it still needs a little bit more refining and to mature to, I don't know, let's say the project that is the standard for doing that. But a lot of people are already working on it. So, and for a couple now for over a year. So I think the community has taken Swift very well. It needs to go faster and faster. And now with Swift 3, the package manager is also available. So that's also going to be a game changer for developing the language.
okay, so that replaces Cocoa Pods and
That's the idea.
Okay.
That would be the idea, yes, absolutely. I think that even for the package manager, the guy from Homebrew was working on that. So it's kind of a reputable effort.
That makes a good transition to my thing. One thing I wanted to point out was actually the Swift project has a server APIs thing that they just announced this week, which is kind of interesting. So all of the Swift server side platforms are kind of consolidating and working explicitly on some of the issues like solving better networking in Swift and some other things to make Swift a more viable server-side platform. So it's kind of interesting that the language team itself is working on making it a viable server language. Anyway, thanks a lot for your presentation. And